Hey there. So I'm here for a little talk about the moon in relation to flat earthers and flat earth ideas. I've spent the last 4 months online amazed that day after day by what I see from flat earthers in some of the memes and in my discussions. And at first when I started looking into this, I thought there'd be something interesting and that some of their ideas might be interesting. I was open for that. I wasn't looking to switch, but I was open. I thought, well, they might have some really interesting points. But time and time again, when you look at the geometry of things, it comes down to quite a simple thing. Like, for example, let's just take a look at the moon here. At the moment, I'm involved in a debate on the moon with somebody, and I noticed one of their favorite tactics is to tell you to do they talk about some really little detail that has to be calculated or looked at in depth. And a lot of those require big calculations. Like, for example, oh, well, the Earth is spinning, and then the Earth is also going around the sun, and the Earth is also, and the solar system is going around the galaxy, and all this stuff should throw everything off. And you know what? If you sit down and do the calculation for the Earth's spin and the spin going around the sun, and then you add and then I actually did the calculation for how much acceleration it causes, centrifugal force it causes by going around the galaxy. It's the total force exerted by the gravity of planet Earth is 250 times greater than all these forces combined when they're acting at their worst. So they say these things to a lot of people who will A, not know how to do the calculation, and B, will feel overwhelmed by the calculation and won't even do it. And right now, one flat earther is trying that with me with the moon. They're saying that I should go out and do this calculation on rotation and this this few degrees here and the. Okay, let's go through and take a look at the problems with the moon, just from what we can see. So, just a visual observation here. And by the way, when I say HSEM, that means heliocentric spherical Earth model, right? Because I don't want to say that every time. So let's just take a look at Moonrise and Moonset. If you take a look at the flat Earth model, and you look at the Earth at the moon going around in circles above the Earth, the flat Earth, you can see that it can only create moonrises and moonsets. Moonrises in the northeast and moonsets in the northwest. Only. It's incapable of producing moonrises to the due east and moonrises to the due west. Same problem with the sun. Here's a map that I did from another thing that I did for the sun, but it's the same problem for the moon because they're both going around in circles like this. And the problem is, like in places like, well, it's everywhere it's the problem, but it's especially clear in the southern hemisphere. Like, for example, in Perth, Australia, when the moon or the sun go around this way and it disappears over the horizon, it always has to be to the northwest. Whether it's the moon or the sun, it will always have to be to the northwest if it's setting. But we know, and everybody knows from daily observation through our lives that it doesn't just disappear into the northwest. It also disappears into the west, and it disappears into the southwest. You can look this stuff up all over online. It's not just the case for the moon, it's also the case for the sun. And it doesn't matter. Even if this happens in Chicago or at a high latitude, it's still to the northwest, and there is still no possibility of a western or southwestern sunset. And the same problem occurs, when it's coming in from the northeast for the sunrise. This just doesn't work at all. And then they want to tell me that I should worry about this degree and how many degrees and what if you do okay. Right, so let's just talk about the fact you can't get a freaking moonrise correct to within freaking 90 degrees of the sky, or moonset, or sunrise or sunset. Okay, but here we're talking about the moon, right? So that problem is geometrically baked into the heliocentric heliocentric spherical Earth model. It's baked. We can do this really easily. It's exactly what the model does. We don't have to cheat, and we can, and they can't even do it. I don't even know how they would cheat to do it. So we see one face of the moon. Number two, we see one face of the moon. How the hell is this possible? How would, on a flat Earth with a moon going around 3,000 miles up, that's about what all of them say it is. Nobody says crazy distances. They all say, oh, it's a close moon. Just like they say, oh, it's a close sun. So how would we all, now we have one advantage with the moon is that it's not so bright that we can't see some of the features on it. So we can see the features on it, and we can see that everybody sees the same face of the moon. How the hell would that be possible on a flat Earth? If there's a spherical moon going around, everybody would see a different face of the moon, right? But we all see the same face of the moon. And how do we know that? I've actually talked to flat earthers who say, oh, but I don't know, that's not the case. You know, my friend and I were talking, blah, blah, blah. Well, here's the problem, is you can go anywhere online and you can look up what the moon looks like during lunar eclipses. Why? And why is that interesting? Because all the amateur astronomers around the world on that side of the Earth facing the moon at that moment, at the same moment, are taking the pictures. So we know that all those pictures represent the moon at the same moment, and I'll talk about that more in a second. So, how's that even possible? Well, sorry, I got a small thing here. So, how's that even possible? Well, this is actually baked in, geometrically baked into the HSEM. Right, so we all see one phase of the moon. Well, how's that possible? You know, if part of it's if it's a close moon and it's going around, how is that even possible that we all see the same phase? Wouldn't some of us see it from one direction? So, like if you're seeing it from behind, like if you're seeing it from that side, wouldn't you see a full moon? And the problem is, wouldn't you see it in different phases? You know, all night long it would change? No, but we see the same phase. One phase, we all see the same phase, and we all see it all night long. How's that possible? Well, they like to talk about self-illumination. That's coming up. So that's baked right into the HSEM. That solution's baked right in. We don't need an illusion. They need an illusion for that. They need an illusion for they need a massive illusion for the moon. How you're going to move that 90 degrees in the sky. They need a massive illusion for that. They need a massive illusion for seeing one face. I hear some of them say, "Oh, well, maybe it's a light, you know, that's with a bulb." I haven't seen anybody reproduce a spherical a spherical object that's projected down through whatever, and then looks like a sphere, but it's not. It's a projection, so that's why we only see. Okay, whatever. So you need another illusion for that. They need one for that. So we need to see one phase, right? So they need another illusion for that, unless they do, the projection thing with the. Moonset geometry. So geometrically speaking, the flat Earth moon should never be hidden. We should always be able to see it. It's above a plane. We should see it, and it should never even come closer than 5 to 10 degrees to the horizon, based on simple calculations you can do. It should never even be closer than that to the horizon. So why don't we ever see, geometrically speaking, so why don't we ever see the actual transition to the part of the sky where we cannot see it? Isn't it convenient that it disappears below the horizon for them, because it should be just fading away into the sky, right? It shouldn't even be going below the horizon. Well, you know what? HSEM geometrically baked in. We do that without breaking a sweat. Just the way it happens. Angular velocity. So there's for the flat earthers, there's an optical illusion required to make the flat Earth moon appear to have a constant angular velocity in the sky. So the moon goes through the same 15 degrees per hour approximately, but it goes through the same angle per hour, right? So I want to quickly take a break here and tell you why that's important. Imagine if you are standing at the side of a street, 10 feet away from the street, and a mile off in the distance, a car is coming towards you at 50 miles an hour, or about 80 kilometers an hour. At first, your head, if you want to track the car, your body and your head do not have to move much to follow how fast that car is coming. or to follow the car as it's coming towards you on that straight road that you're standing beside. And then as it gets closer, you kind of have to turn your head a little faster, and it gets closer and a little faster. And then right when it zooms by, your head has to move very quickly. And that's angular velocity, how quickly your head has to turn. That's the angular velocity of your head. Now think of this situation. Now imagine standing in the middle of a huge circle of a road that has a radius of about 400 meters, and the car is driving around that circle at a constant 50 miles an hour or 80 kilometers an hour. It's always driving at the same speed. Now, your head following that car is always has to turn at the same angle per second, right? You don't have to turn your head faster or slower at any point. It's always turning at the same speed. That's angular velocity. And for a moon traveling over a flat Earth, zooming towards you, you have a situation. All that matters to create this change in angular velocity is that it's moving towards you and away from you, right? That's what creates the angular velocity. And on a flat Earth, if the moon is zooming towards you and getting closer during the day, or the sun, either one, the angular velocity goes up until, just like with the car, right when it's overhead, it's moving at its fastest. And on a spherical Earth, where the moon is moving around you at a constant speed, it's always moving through the sky at a constant angular velocity. So I'm sorry for the break, but I had to make that quick explanation. But because our moon is about 3,000 miles above the plane of the flat Earth, as they say it should be, then it should have an angular velocity, this is crazy, about 4 times higher when it's overhead than when you first see it. Right? It should be moving 4 times faster as an angle through the sky when it's overhead. Again, because it's really far away, ours moves at a constant angular velocity through the sky. That's baked right in, geometrically baked right in. Angular size. All right, so they need another optical illusion to correct for the angular velocity deviation, but it has to bend the light differently for different people so that everybody seeing it in different places has the angular velocity somehow magically manipulated into appearing that it's a constant angular velocity. So what's really weird you'll find about all these illusions required is that they're all illusions required to make it look like a spherical HSEM system. Why would that be? Why would the illusions all be tuned to make it look like an HSEM system? So then there's angular size. It's another optical illusion, a different one required to make, because it's not going to be the same bending of light that causes this illusion and the other one. So optical illusion required to make the flat Earth moon appear to have the same angular size throughout its trip across the sky. It might vary just a little bit very close to the horizon, because when you look through a lot of atmosphere, there is a problem. But once you get just a few degrees off the horizon, it's the same angular size throughout the sky. So I did some simple calculations on this, and if they say it's 3,000 miles up, it should be about 3 times as wide when it's overhead, 3 times from one side to the other, as it is when we first see it. But it's not. But there's an optical illusion to make it appear that it's the same angular size, which copies an HSEM. Geometrically baked right in, HSEM. So how is the moon lit? Well, most flat earthers actually say, I couldn't believe when I heard this the first time, actually say the moon is self-illuminated. It doesn't get lit by anything. But how does this work with the shadows in the craters? Why would there be shadows in craters if it's self-lit? How does that even make sense? The other question is, how would this work? How would a lunar eclipse then even work? If it's self-lit, why would there be any lunar eclipses? It doesn't make any sense. I thought it was self-lit. So again, the moon is lit by the sun in the HSEM model. It's geometrically baked in. Quite simple. No illusions required. Lunar eclipses. Why would there be lunar eclipses at all if the flat Earth moon is self-illuminated? Why would there be lunar eclipses? Why would a shadow appear here for no reason. And then what's really interesting is why would they appear specifically, exactly, when, let's see, do I have that one next? Oh, there we go. Yeah, but why would these shadows appear specifically and exactly when the spherical Earth model predicts that the Earth is going to come between the moon and the sun? Doesn't happen any other time, only when the HSEM model predicts it's going to happen. Very strange. So another solution that's geometrically baked into the HSEM. Lunar eclipse problem 2. Photography from all around the world at the same moment. Now this is exactly what I was talking to that person about, and she said, "Oh, but I've talked to people on the other side of the world who say it's the same way up." And we looked outside at the same time, and I was like, "Oh God, it's another one of these flat Earth delusions or lies." And I've got another 25-minute video coming out on an outright freaking lie that I caught one of them in, where I do like a large calculation for a location in the southern hemisphere, what they say that they saw and should have seen, and I show that with trigonometry it's clear that the image shows exactly what is expected, and they're just a freaking whatever con person. Anyway, so lunar eclipse 2. So from photography around the world at the same moment, because then this person said to me, "But all those pictures, we don't know, from one night to the next." I was like, "Oh, you know what? That's wrong." Because when lunar eclipses occur, half of all the amateur astronomers and regular people are out on the planet taking pictures of this event, and these pictures are at the same moment. I think they're virtually at the same moment, and it does show, if you look at where the pictures were taken, that there's a slow 90-degree rotation as you go from the northern hemisphere, from Great Britain down to 45 degrees in the southern hemisphere, about Buenos Aires or Australia. It rotates exactly as the spherical model predicts it does. So again, don't know why that would happen on a flat Earth, geometrically baked into the HSEM. Lunar eclipses, number 3. So what casts the shadow, if the shadow that doesn't need to exist, what casts the shadow on a flat Earth moon during the lunar eclipse? Like some say it's a shadow object, something that we can't see, can't detect, but is big enough to cast a shadow on the moon. At exactly the same moment that the Earth comes between the moon and the sun in the HSEM. It's funny that it only shows up right at that moment. Down to the minute, it makes its appearance. So what is casting that shadow? It doesn't even make sense. I mean, why would they need that? Why would lunar eclipses even occur? It's crazy stuff. Oh, once again, HSEM geometrically baked in, right? The Earth does it. We don't need another illusion. We don't need more. And again, this is all geometry. I'm not even going into physics. I'm not going into higher order stuff here. This is just simple geometry, right? Lunar eclipse number 4. If the shadow objects exist, why don't people all around the Earth see the shadow event from different directions? So let's say it is a shadow object somehow casting a shadow. Why would they? But then the question is, why would a shadow object be needed? Somehow, if we can't see the sun that's casting the shadow on the moon, so what? The moon can see the sun, and then the shadow object comes between that, even though we can't see the sun. Oh man, it's not. So if that's the case, then why wouldn't, if there is a shadow object, then why wouldn't people around Earth see this lunar eclipse happen from different directions? Some people seeing it from the front would see the shadow being cast by the shadow object, but people from behind wouldn't see it, right? But this is also insane. I'll tell you.
The Kaguya moves toward the South Pole on the far side of the moon. The blue Earth has appeared from the horizon. This is the Earthrise, as captured by the telephoto camera. The sun is located right behind the Kaguya. The sun's light is projected directly onto the Earth, which appears round like a full moon. In this footage, the Earth's southern hemisphere appears on top. This is a spectacular view of the beautiful planet we call home.
So here's the problem, is that all of these illusions required, all of these bending, massive, hugely bending of, how do you get light to 90 degrees somewhere else on the horizon? All of this stuff, imagine if you tried to put this into a program, a computer program, and create a piece of astronomy software which would allow a flat earther to go out to predict what his backyard would look like anywhere on Earth at any time. All the contradictory light bending equations that would be required to make all this happen would be impossible even for Disney to solve, which is precisely why you do not see any flat earther astronomy software that lets you predict any backyard anywhere on Earth at any time and let you zoom out to see how that's happening. There just isn't one. They cannot make, you see all the time, oh, there's a sun and a moon going around, but you do not see what kind of a view that would create standing on the flat Earth looking up, right? And the problems with the stars and constellations, oh my God, that's a whole nother thing. And the problems with the sun, that's a whole nother thing I want to do a more in-depth video on. And you add all these things together, the only place all these contradictions work is in the mind of a flat earther. They cannot even force it to work in a computer, right? In the most logical, impartial referee on the planet, they can't even force all this shit together to make it work, to bend the light in all the different types of directions required for each different illusion, which coincidentally copy an HSEM, a heliocentric spherical Earth model. Why? Okay. Really, how crazy do you think we have to be? And then these people who also cannot do the most basic of water physics calculations want to tell us about the physics of water. And the people who cannot even do the most basic of centrifugal force calculations want to tell us, and can't do, really, I haven't met a flat earther online who can do math at 12th grade level or above. And they want to tell us that the Earth is spinning so wildly everything will fly off and hurtling through space. So it's also crazy. It's like I said, the only place all this stuff works together at once is in their imaginations. So there we have it. I don't want to waste any more time with this. I got to get going. I have stuff to do. I hope you have a great day, and thanks for stopping in. Looking forward to comments below. Have a great day. Subscribe, like and subscribe, please. Bye-bye.